So in this video we're going to find the mean of the beta distribution. Now the beta distribution is written like this: beta A comma B, and A and B are its parameters. So A and B are also greater than 0. Now, important before we can calculate the mean of this distribution is to know the support of this distribution. So the beta is normally interested in probabilities. So our random variable x, that's normally in the range of 0 to 1. So that's our basics of our beta distribution. The next thing we need to know is what the probability density function is. So PDF probability density function, we can write that as f of x, that's our random variable, and given A and B, which are our parameters, this is written as gamma of A plus B divided by gamma of A times gamma of B, and then next to that comes a polynomial. So we have x to A minus 1 and 1 minus x to B minus 1. So the probability of it happening, probability of it not happening, to the A minus 1 and the B minus 1. That's our parameters, and that's where our random variable comes in. So that's quite a complicated looking PDF. So in the past, when we've found the mean of a distribution, what we've done is we've used integration. So the mean, which is the expected value of x, we write that as from negative infinity to infinity of x times our PDF. So I'd write x times f of x given our parameters a and b with regards to x. So that'd be our basis to start with to find our mean. Now the integral here is calculated from negative infinity to infinity for all distributions. While here we're only dealing with the beta distribution, and we know that the beta distribution goes from 0 to 1. So from negative infinity to 0, this integral is 0, and also from 1 to infinity, the integral is also. So we need to concern ourselves with parameters of integration from 0 to 1. So we can just put them in there. So that then becomes our parameters. Now we can write in our PDF. So now we've got from 0 to 1 x times all of this, and that looks quite complicated looking integral to deal with. So gamma A plus B, gamma A, gamma B, and then this polynomial. Okay, and all with regards to x. Okay, so now, yeah, this looks a really complicated integrand. Very unlikely we could deal with this with elementary methods of integration, so we're going to have to call on some of our identities as we go along here. So first things first, what can we do before we call on any of that? Well, these gamma functions, which are related to the factorial function, these are only regarding a and b. So our integral variable, which is x, this is not included. So we could rewrite this with this out of our integral. So let's write that on the next line. Gamma of a plus b divided by gamma of a times gamma of b. So that's that taken out. Okay, so now we can put the integral in there. So the integral from 0 to 1. Now x to the a minus 1 times another x. Let's write that as x to the a minus 1 plus 1. That would deal with all that. This one here, nothing we can do. So now we've got 1 minus x to b minus 1 dx. Okay, now it's a little bit simpler, but it's still, we're not gonna be able to integrate that with those kind of parameters there. So what we need to do now is call on an identity. So what we know is, if we integrate from 0 to 1, our x to the a minus 1 times 1 minus x to the b minus 1 with regards to x, that integral there will just become the reciprocal of this gamma term here. So then we have gamma of A times gamma of B, and then we divide that by gamma of A plus B. Okay, and that's on the principle that we've got A minus 1 and B minus 1, and this two terms here with our different powers, and from 0 to 1. So that's an identity we can call on. But here we've got this one here, that's fine, that looks a little bit like that, so that's good. But this one here, we've got x to the a minus 1 plus 1. That's not what that says. So if we draw a bracket round that, you've got x to the a minus 1 plus 1. This a term now is increased by 1. So what we could do is we could use this identity, and where we see an a, we add 1 to it. So we've got a plus 1. And that would still work, and that's fully legitimate to have our integral expressed as that. So then we don't need to do any integration, we just substitute this into this one's place. So let's do with that. So we've got gamma of A plus B divided by gamma of A times gamma of B. And then this integral here, we just multiply using this identity. So we've got A minus 1 but plus 1. So then we need to put a plus 1 in here in our gamma input. So A plus 1, gamma of B would not be affected. So that's still B minus 1, so that's fine. Now here we've got A plus B. So now we need to divide by gamma of A plus 1 plus B. And that would take care of that. Okay, so now we're going to hope now we can see some cancellations. So we've got gamma of A plus B and gamma of A plus 1 plus B. So we need to do something with that. And we've got gamma of A plus 1, gamma of B, gamma of B. Well, that's a bit of luck. We can cancel those gamma of B's out. Okay, so gamma of A plus 1, we could rewrite that using a gamma identity as it's related to the factorial function. So gamma of A plus 1, that's the same as writing, as it because it's factorial, as A times gamma of A. So we can input that in there. So let's start that on the next line. So now we've got gamma of A plus B over gamma of A. So that takes care of that. And now we've got gamma of A plus 1, which I'm going to rewrite as A gamma A. So now we can include this now on all the same fraction. So A times gamma of A. So now I can see a cancellation coming. That's great. Now what about this one? Here we've got gamma of A plus 1 plus B. So using this identity, let's write that as gamma of A plus B plus 1. So basically it's just 1 more than A plus B. So then we know that this would be A plus B gamma A plus B. That would take care of that. So now I can rewrite this denominator using this identity here. So now I've got A plus B times gamma of A plus B. So now using that I've got some cancellations. So gamma of A, that's gone. Gamma of A plus B, gamma of A plus B, that's also gone. So now I'm just left with A divided by A plus B. And that is our mean, that's our expectation of x. So E of x equals A over A plus B. Okay.